Okay, hi. Welcome back to the Physics 1108 lab videos. Today we're going to be doing a lab about waves. And waves are sort of mysterious objects. They are things that aren't nearly as real looking as matter, and yet they turn out to be just as important in a physics view of the universe. Waves are really just disturbances in some sort of medium, meaning that you have some big extended thing and there's a pulse of some sort traveling through it. Now, the best example I know to start people with is the wave in a football stadium. If you have a big football stadium with 100,000 fans and they all do the wave, what's going on? Well, each and every person is just standing up when it's their turn and then sitting down again. And what happens from the outside, looking at this whole thing, you see this big wave propagating around the inside of the stadium. And if you have an oval stadium and a good crowd, it can go around 2 or 3 times. It can be fairly fun. It's actually very impressive that these things happen. Let's think about it physically. What are these people doing? Are they moving along with the wave? No, they're just standing up and sitting down. They're not even moving in the same direction that the wave goes. The wave goes sideways and they're going vertically. The wave is moving quite independent of the motion of anybody involved in it. Nobody in that whole crowd is moving with the wave, and yet the wave is clearly there. It travels around the stadium. You can see it. It's huge. It's a big thing. This is what waves are like. There's a medium, which are the fans, and those things basically stay in one place. They move a little bit, but they essentially stay in one place. And then there's the wave, which is the disturbance, and that moves independently of the medium. The medium stays in one place, the wave travels. That's the big secret about waves. It's very easy to get these two things confused. Don't. They're separate. They do different things. Eventually, it will turn out that waves are just as real as the particles they travel through. They can carry energy, they can carry momentum, they can carry angular momentum. They're just as real as the matter. And that was a big surprise when it turned out. They certainly don't look as real, but they are. And we're going to start talking about them today. We will continue getting back to waves through the rest of the course. It's basically half of what physics does. So, to review, when you're talking about waves, there's a wave disturbance and there's a medium. They do different things. There are many ways to classify waves, one of which is the longitudinal transverse distinction. And a transverse wave is where the particles in the medium travel perpendicular to the way the disturbance goes. In a longitudinal wave, the particles of the medium travel in the same direction, same dimension as the wave disturbance goes. One example of a longitudinal wave is sound. Sound is a wave propagating through air. And what happens is the air particles move a little bit back and forth like this. And as they do that, the wave disturbance moves in the same direction as the air molecules are going. Another example is a slinky that we'll play with in a minute. A transverse wave is what you find in a rope. If you pick up a rope and you snap it at one end, there's a wave disturbance that goes this way, goes up and down. The disturbance moves that way. The medium particles are oscillating up and down. That's a transverse wave. All right, That's the introduction.